Okay, this is your video lessons on segments, rays, and distances. I'm going to concentrate on terms. Now, some of the terms here are, I'm going to add some stuff to the verbal description. So you may want to pay attention to the words and not just watch the video without the words. Um, we're going to talk about segments, rays, and distance. Okay, and then some other things that go with that, some specific types of distances. So the first term is segment. And the words here quite don't give it away exactly what a segment is. So I'm going to use the illustration to help you with that. So in the illustration over here, we have ourselves a segment. That segment is all the points on a line between two endpoints. So over here, they're basically describing a segment is named by giving its endpoints. A couple things to note is that if x and z are the endpoints, we write it as xz, but we put a little line segment on top. See the little line segment? But xz is the same line segment as zx. So we have two ways to write it. Now, this is a statement that helps us with this picture here, over here. Basically, the word between, you don't have to necessarily write it down. I think you can intuitively understand this one. If y is between, when we say between x and z, that means y has to be on the same line falling in between. Okay? So it's important you understand that if y happens to be between, it has to be on the line xz. I know it seems common sense wise, but it's not always that way. Ray. Now a ray, and I'm sure you've heard these terms before, I don't want to sound redundant, but a ray has an endpoint and all the points that go in one direction. Now, if we're going to do that, we have to have this one endpoint. We start with that term, that letter. So we're going to write x. Now, what we can do is, and we're going to put a little ray symbol over top, but we have to write the endpoint first. Now we say which direction. Now, we could say it's in the direction of y, or we could say it's in the direction of z. So two ways to write this one would be xy or xz. They are the same exact ray. Now, if I switch the order, notice if I have start with x and then I start with z, those are completely different rays. Now, in the event that we have this picture here, we have a term called opposite rays. You can make a separate flashcard or put this on the same flashcard as ray if you want. But opposite rays are ones where they have exactly the same endpoint, but they go in opposite directions on the same line. So here's why. If I go ray yx, I'm going in the left direction. On the same line, if I go yz, that is two rays on the same line going in opposite directions, hence called an opposite ray. Now we're going to try these four questions in class and these 1 through 12 in class. Now we're going to go to the next term. The next term is length. There's multiple ways to ask for a length. A length is the distance between 2 points. Distance between 2 points. We can say that's the length of the line segment. Also note, if I just want the length of a line segment, I don't have to put any symbols over top of it. In other words, if I use 2 capital letters, any 2 letters, that means the length of xz, line segment xz, or the distance between x and z. Okay, so nothing atop means I'm looking for a length of all between those 2 points. Okay. Now on a number line, we can compute those by subtracting the highest value from the lowest, and we're going to do those examples at the end in class together. Okay. Now, there's some rules about geometry. So you have definition rules. So we need all of our definitions and rules in flashcard form. Again, there's so many of these that we want to every day get rehearsed on it and practice it, because at the end of the day, if you get yourself to know these, all the other stuff, all the work that we have to do with them fall into place. If I don't know these, I can't do anything. I just basically don't understand what's going on. Now, basically, this is the addition possible of segments. Basically, it means that I can take any point B between 2 points. I can take and add the length from A to B, add the length from BC, and I get the length of AC. In other words, if I have a length AB and I know its length is 3, and on the same line, I have the line segment BC, and I know its length is, say, 5. The postulate that this one is, and that you wrote down, it's in your flashcard, and basically you write this down, you can use this as your illustration. Basically, the length of AC, notice I didn't put anything on top, that means length, equals 3 plus 5. Hello, I got it, 8. Okay, turn the page. Okay. Now again, you don't have to. All you're doing is filling out flashcards here. We're going to actually get the copy of this, and we're going to be working on this in class. So here's an illustration of what I just did, where I used, and this is more complicated because it has algebra. But basically, here's where I took SR, and I'm going to add RT to get ST. In other words, the length SR plus the length RT plus the length ST. Okay, back to your terms. Again, this is the only focus for tonight, is just to write these down. Congruent. Congruent are any two objects that have the same size and shape are congruent. Now, the symbol we use is this one. So on your flashcard, you put congruent, you write this term, two objects that have the same size and shape, and then I want you to put that as your symbol. Okay, so on the back side, you're putting the terms and your illustration. Now, if in fact, the example, if the length of AB and the length of CD are the same, then that means the two segments have to be congruent. Notice I used the congruent. Here, we're not using the congruent symbol because we're not talking about shapes. See how it says two objects that have the same size and shape? Okay, so there's a difference between equal and congruent. Equal is for lengths, where congruent is for shapes. And that's just no two ways about it. So I can say here that, and here's the illustration that they're talking about, AB, that length, is the same thing as length CD because they're both 5. If the lengths are the same, then I can say line segment AB is congruent to line segment CD. Next term is midpoint of the segment. Well, that seems pretty logical. A midpoint divides the segment into two equal congruent segments. Or you can say that the midpoint divides a segment into two equal lengths. Okay, X is the midpoint of AB would mean that if that's true, then I've divided it into two congruent shapes, or I can also say the length XAX equals length XB. And here's, again, is your illustration. Okay, I have a midpoint. The midpoint is X. I think this is the last term. Um, these two kind of go together real well because it's just a way of defining things. So in this particular example up here, x right here, x x is the bisector of the segment. So your flashcard, one's first side will be this. Your second side, you'll say a segment bisector is a line, segment array, or a plane that intersects a segment at its midpoint. Okay, so we can not only can we cut a line in half, we can cut planes in half as well. So this illustration here, A, B, seems pretty logical that we can say X is the bisector, but we can cut AB, this length, in half by using other tools. Like, for example, when we got the point, we can use the point, but we also can take a line segment and cut it in half by going through X. We can also take a line to cut AB in half, as long as it goes through X. And then we can take this plane, M, as long as the plane only touches the line segment at X, it also can consider the slicer or the cutter in half. So a bisector can be any of four things: a line, a segment, array, or a plane. It also can be a point, but we usually refer to that as a midpoint. So bisectors are any shape that can cut it as long as it goes through its a midpoint. And again, we'll practice this later. So have those terms on your flashcard, and we'll do the practices in class.